Guys, sorry, now we'll get started. I wanted to give everybody this chart. I gave it to everybody in class printed out. You guys, I posted it on Google Classroom for at home. I would keep this chart handy. What's going to happen this week is we spent last week reviewing how to simplify square roots, and then we saw how to simplify in algebraic square roots, right? The square root of a number, the square root of a variable, and all that. We're going to do the exact same thing this week, except instead of doing it with square roots, now we're going to do it with third roots and fourth roots and fifth roots, etc. So when you were simplifying square roots, you had to know what numbers that you are able to take a square root of. Well, now we're going to work with third roots specifically today. If you're going to simplify a third root, then you need to know, well, what numbers can I take a third root of and get a whole number back? You need to know what are your perfect third powers in order to simplify a third root radical. Well, guys, being that you're probably most familiar with square roots and you probably don't work with third roots all that often, I would never expect you guys to know what are all of your perfect third powers off the top of your head. And when we work with fourth roots, I would never expect you guys to know, well, what numbers can I take the fourth root of? What are my perfect fourth powers, okay? Because these are just numbers that you're probably not that familiar with because you haven't used them all that much. So if we're going to work with third roots today, like I said, I need you to know your perfect third powers. I need to know what numbers you can take the third root of. So I've created this powers and roots chart for you. This is just going to save you a lot of going back and forth between a calculator and stuff. This will really save you time. So what it is I've listed numbers on the left side, the numbers 1 to 10, and then I've given you either a power or a root across the top. So guys, if I asked you, what is 5 squared? What is 5 to the second power? You would find the number 5 on the left, and you would find a power of 2 at the top. What box do they meet at? 25. 5 squared is 25, right? But you probably know that because you know your squares, right? What is 8 squared? It's 64. So if you notice, in this power of 2 column, these are all your perfect squares. These are all numbers that you can take a square root of. I need you guys to be able to recognize perfect third powers. So if I asked you guys, hey, what's 5 to the third power? Find a number 5, find a power of 3, and they meet at the box 125. So 5 to the third power is 125. So now you don't have to worry about putting that into a calculator. You can see it right on the chart. If I asked you, hey, what's 8 to the third power? Find the number 8, find the power of 3, they meet right there. 8 to the third is 512. It's just going to save you a lot of time. And guys, it works for a lot of powers. If I asked you, what's 3 to the sixth power, find the number 3, find the power of 6, they meet right there at 729. So it's really going to save you time when you're trying to look at powers. It also means that if this is my power of 3, then this column are all of my perfect third powers. These are all the numbers that I can take the third root of and get a whole number back. Just like these are all the numbers that I can take the square root of and get a whole number back. So guys, when we're dealing with third roots, this third power column is going to be our best friend. These are the numbers that we're going to have to look for. So the chart also works in reverse. So if I asked you guys, what's the third root of 125? Find your third root column, look for the number 125, and take it all the way home to the left. What number do you land on? 5. So the third root of 125 is 5. If I asked you, hey, what's the third root of 512? Go to your third root column, find the number 512, take it all the way home to the left, it's 8. So instead of you having to type all this into a calculator, the chart should help. If I asked you, what is the fifth root of 3,125? It's 5. So you can use the chart to help you. So I hope the chart makes sense because this is what we're going to need to be able to do. And when I ask you guys to simplify a third root radical, then these numbers in your third root and third power column, these are going to be the numbers that you have to concentrate on, okay? All right, let's look at our notes then. All All right, so guys, if you look at your notes, I'm going to have to do a lot of flipping back and forth. But today, instead of working with square roots, we're going to concentrate on third roots, right? It's how you unthird power something. So this is the third root radical symbol. It's going to have a little 3 tucked in that corner as the index or the root, right? And then I've listed at least some of them. These are your perfect third powers. 1 to the third is 1. 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. So all of these numbers are the numbers that you're going to be able to take the third root of. These are your perfect third powers, okay? And then if we do it with a variable, remember, if I take the third root of x to the third root and the third power are canceling each other out, and they're leaving you with just x. If I take the third root of x to the third, I'm trying to find what can I times by itself 3 times to equal in x to the third. In x, that's what I have to times by itself 3 times to equal x to the third. Okay, so for each x to the third that you take the third root of, it's going to equal a just x. Just like the square root of an x squared was a just x. A third root will undo a third power. Okay? All right, so guys, let's practice some. I have a ton of examples, guys. I have way too many, so I'm going to have to skip around a little bit, but I want to do the beginning to kind of get you guys started. And I'm going to have to flip around a lot between this and the chart. All right, so let's say I asked you guys to simplify. What's the third root of 512? Well, this is what I would tell you guys to do. I would go to my chart. We've been asked to find the third root of 512, right? So go to your third root column, cross your fingers that there's a 512 somewhere. And there it is. Take 512 all the way back to the left, and what number do you land on? 8. So the third root of 512 is 8. Because the third root of 512 is literally asking you, what can you times by itself 3 times that will equal 512? Guys, it's 8. 8 times 8 times 8 is 512. So the third root of 512 is the number 8. And that's how the chart will help you. It'll be right there in front of you if you just have to use the chart. Otherwise, let me show you how to do it on the calculator. Well, I can't show you, but I can tell you. If you want to take the third root of 512 using a normal calculator, clear your screen and put the number 3 on it. I'm taking the third root, right? So you take the number 3, you put it on a blank calculator screen. Then you have to go get this symbol. It looks like a square root symbol, but it has a little X tucked up in that corner. Usually you have to press like the second button, and then this is written above another button to get to it. But the minute you put the 3 on the screen, and then you go get this button, you're given this X a value of 3. So you'll be taking the third root of whatever number you're about to punch in. So then you would punch in 512, you would hit enter, and your calculator is going to spit out the number 8, okay? That's how you would do it on a calculator. I have the chart here for you so you don't have to use the calculator. And I would always, when we were in person, I would allow students to use this on a quiz. This is better than a calculator to me, okay? All right, so the number is 8. Let's go to the next example. The next example, I'm going to say on the chart, it says, what's the third root of 125? What number can you times by itself 3 times that will end up equaling 125? Well, guys, it's the third root. So go to your third root column, cross your fingers, and hope there's a 125. There is. Take it all the way home to the left, and what number do you land on? 5. So the third root of 125 is 5. All right, go to the next example. The next example is, what's the third root of negative 64? Well, guys, time out. When we took the square root of a negative number, there was no real number answer to that. We got an imaginary number when you took the square root of a negative number. Because with real numbers, nothing times itself twice should end up negative. So you can't square root a negative number and get a real number answer. But guys, if you're third rooting something, you're trying to find out what times itself 3 times equals that number. And if you times a number by itself 3 times, it could definitely end up negative. So there are no imaginary roots when you take the third root of a negative number. You do not get the I to come out in any of these problems. If you take the odd root of any negative number, it's going to be a real number solution. Something times itself an odd number of times could end up negative. All right, so do this. Forget the negative for now. The third root of 64, right? The third root, hope and pray for a 64. There it is. Take it all the way home, it's 4. But it couldn't possibly be a positive 4 that you times by itself 3 times to get negative 64. It must have been what kind of 4? It must have been a negative 4. So the answer to this is negative 4. There will be no imaginary roots when you are dealing with a third root radical. So you should not have I come out to play in any of your third root radical problems. Okay, now go to the next example. The next example is the third root of 24. Guys at home, are you okay with me doing it off to the side? I'm just trying not to leave the chart. Is everybody okay? Okay. So the third root of 24. All right, so normal. We're taking a third root. These are all the numbers that we can take a third root of. So let's go to our third root column. Let's look for a 24. Well, damn, it's not there. It went from an 8 to a 27. 24 is somewhere in the middle of there. It gets skipped over. That means that 24 is not a perfect third power. He's not a number that you can take the third root of and get a whole number back. He's somewhere in between 2 and 3. He's going to be some 2 point something decimal. And we don't want decimals. We want simplified, exact answers. So just like we did with square roots, we would find the biggest perfect square that divided evenly into that number. Well, now I need you to find me what's the biggest third power that divides evenly into this number. All right? What's the biggest number that we can take the third root of that divides evenly into 24? So guys, go to your perfect third powers, go to your third root power of 3 column, find me the biggest number in this list that divides evenly into 24. Well, guys, all of these numbers from 27 down are bigger than 24. So they're clearly not going to divide evenly into 24. So that gives you 2 options, 8 and 1. And let me give you a hint. We never use 1 because he doesn't change the number when you divide something by 1. So either it's going to be 8 divides evenly into this 24, or 24 is an already simplified third root radical if no numbers divide evenly into it. But guys, does 8 divide evenly into 24? Yeah. So I'm going to be able to split this. We're going to write it as the third root of 8 times the third root of what number is left over? 8 times what gets you to 24? 3. So just like with square roots, we split them into numbers that we can take the square root of and numbers that we can't take the square root of. Now we're splitting it into a number that I can take the third root of and a number that I can't take the third root of. So guys, now we go through. What is the third root of 8? The third root of 8 is 2. And then the third root of 3. I get it, guys. It looks very pretty. Most students are like, the third root of 3, it's 1, right? No, because the third root of 3 is saying what number times itself 3 times equaled 3? Does 1 times itself 3 times equal 3? No, 1 times itself 3 times is 1. So believe it or not, the third root of 3, guys, it's an ugly decimal. You can't take the third root of 3. Is the number 3 anywhere in your third root column? No, because he's not a perfect third power. So he's the leftover, he stays, and it'll be the third root of 3. So the third root of 24 simplifies to 2 times the third root of 3. And that's your simplified answer. So it should feel exactly like what we did with square roots, but now we're using third powers to help us, not square powers. All right, let's try another one. Then it asks you, what's the third root of negative 128? Don't let the negative scare you. Just keep working it. Don't worry about it. Take the third root of negative 128. Well, guys, go to your third root column. Look for the number 128. Well, shoot, it's not there. It went from 125 to 216. So clearly 128 is somewhere in here. If I took the third root of it, it's 5 point something. You cannot take the third root of negative 128 and get a whole number back. So what I need you to do is look at your third powers then, look at the numbers that you can take a third root of, and what's the biggest one of them that divides evenly into negative 128, if there is one. Guys, what's the biggest number in this column that divides evenly into 128? 64. So we're going to break it up into the third root of, give the negative sign to your perfect third power. So negative 64 times the third root of, well guys, negative 64 times 2 gets you negative 128, 2. All right, so now take the third root of negative 64. The third root of 64 is 4, so then this must have been a negative 4. And then the third root of 2. Guys, you can't take the third root of 2. He's not a number in this list. Nothing on this list divides evenly into 2. He's the leftover. He's the part that's stuck. So the third root of 2 stays. So this will simplify to negative 4 times the third root of 2. All right, everybody okay so far? Are you guys okay? Everybody sounding good? At home, thumbs up, we're all right? All right, let's do one more. I think the last one I gave you is simplify the third root of 4,000. Okay, now guys, obviously my chart could go on forever. I could do 11 to the second power, 11 to the third power, 12, 13, 14. I could be here for the rest of my life creating this chart. It would never, ever end. I obviously had to end it somewhere, though, just for time purposes. So I ended it at 10. So when you're taking the third root of 4,000, when you go to your third root column, the biggest third power I gave you guys was 1,000. So maybe you're sitting here thinking, well, gee, Hardy, I don't know. Maybe there is a number when I get down here, and 4,000 is one of them. I'm going to tell you right now, 4,000 is not a perfect third power. So now can you find me a number on this list who's the biggest one that divides evenly into 4,000? And again, the number that we need is not one of the numbers that I didn't put on here. The number we need is definitely on this chart right now. The biggest number on this chart that divides evenly into 4,000 is 1,000. That's my perfect third power that divides evenly into 4,000. So I'm going to split this into the third root of 1,000 times the third root of, well, 1,000 times 2 gets you 4,000. 4. So now take the third root of what you can. The third root of 1,000, the third root of 1,000, take it all the way home, is 10. And then the third root of 4. Guys, 4 is not a perfect third power. None of the numbers on this list divide evenly into 4 because we don't count 1. So that means he's already a simplified third root. I cannot fix him. He is going to be stuck underneath that third root. So it'll simplify to 10 times the third root of 4. Okay? All right, so guys, that's how we do numbers. So hopefully it feels exactly like square roots. You're just doing it with a different set of numbers now, because now you have to use third powers, not squares. Okay, now I want to show you what happens with the variables. The variables are also going to be very similar to what we did with the squares and the square roots. Okay, so guys, let's say, start real easy. If I asked you to take the third root of x to the third, that's our baby. The third power and the third root are canceling each other out, and they're leaving you with just x. Every time you take the third root of an x to the third, you get a just x, right? Because this is asking what times itself 3 times gets you x to the third. An x. The answer is x. So if I asked you, what's the third root of x to the 6th? Well, technically, the long way is you'd have to figure out how many x's to the third can you make out of x to the 6th? How many groups of 3, x to the third, can you make from an x to the 6th, right? Well, the quickest way to figure that out, instead of expanding it, is just to say, all right, this will be equal to x to the power divided by the root. So it'll be x to the power of 6 divided by 3. How many groups of 3, how many x's to the third can you make out of 6? Well, 6 divided by 3 is 2. It's x squared. You can make 2 x's to the third out of an x to the 6th. So it'll leave you with a just x each time, leaving you with x squared as your answer. So remember, last week we were dividing all our exponents by 2 because we were working with roots of 2, square roots. Now we're working with third roots, so our exponents have to divide by 3. All right, if I asked you, what's the third root of x to the 12th? Well, that would be x to the power of 12 divided by a root of 3. What's 12 divided by 3? It's 4. The answer is x to the 4. Because you can make 4 x's to the third from an x to the 12th. All right? Everybody okay? Right? Nice and easy still? All right, what if I asked you, what's the third root of x to the 10th? Here's a problem. This should equal x to the power 10 divided by root 3. Does 10 divide by 3 though? No. So remember last week, if the power doesn't divide by the root, I don't want to leave that as my answer. I don't want a fractional exponent. I don't want a decimal. So if the power doesn't divide by the root, that means we're going to have to split him up. And something is going to stay stuck under that radical. I'm not going to be able to break everything free. All right, so I don't want this. So guys, what's the closest number to 10 without going over that will divide by 3? 9. So we're going to split this into the third root of x to the 9th times the third root of how many x's are left over from this 9 to get back to 10? Just 1, okay? All right, well, now that this power divides by 3, I can take the third root of it. The third root of x to the 9th is x to the, what's 9 divided by 3? 3. So it's x to the third, he's free, he divided. And then the third root of x, guys, he's the leftover. He's the part that's going to stay stuck. He has a power of 1. 1 doesn't divide by 3. Nothing smaller than 1 divides by 3. So he's going to stay stuck. So the third root of x to the 10th simplifies to x to the third times the third root of x. Okay? So again, it should feel just like the square roots, but we're doing it with powers and roots of 3 now. All right, what if I asked you, what's the third root of x to the 5th? Well, this should be equal to x to the power 5 divided by root of 3. Guys, does 5 divide by 3? No, so I don't want this. So we're going to say, all right, what's the closest number to 5 without going over that divides by 3? 3. So we're going to break this up into the third root of x to the third times the third root of, well, guys, how many x's are left over to get back to that 5? Now there's 2, right? X squared is left over. Because remember, only every 3 numbers divide by 3. So you could either have 1 left over or 2 left over, and then that third one will divide by 3. So you might have an x or an x squared left over now. All right, let's do it. What's the third root of x to the third? Guys, that's our baby. That's x. All right, and then the third root of x squared, he's the leftover. He's the part that has to stay stuck, right? 2 doesn't divide by 3. Nothing smaller than 2 divides by 3. So he's the leftover, and he stays the third root of x squared. So the third root of x to the 5th simplifies to x times the third root of x squared. So you're not going to be able to break everything out. All right, well, guys, I know I did too many examples. So just like last week, now you're going to have to put all of this together into like one big problem. All right, and that's what your homework is going to be. So I'm going to skip this one. It's just like these. You're going to have to break it up. I'll have it filled in on your notes if you want to look at it. Let's go down to one of the bigger examples before I send you off and you guys try your homework. Let's do the last example. Let's do that one first. Let's do number 17. Okay. So if I have to simplify this, right? The first thing I would remember is that this negative 2x is attached to the outside by multiplication, and he's just waiting to be multiplied with anything that breaks free. All right, then I would split all of this up into their own third root radicals so we can deal with them one at a time. Since everything's attached by multiplication, I'm allowed to split them. Let's make it the third root of 875 times the third root of x to the 25th times the third root of just y. Just break them up just like we did the square roots. Let's deal with them one at a time. All right, so negative 2x comes down times, let's deal with the third root of 875. So guys, go to your chart, go to your third root column, find 875. Damn it, he ain't there. That means he's either already a simplified third root and we can leave him exactly the way he is, Or is there a number in this column that will divide evenly into him? Well, guys, 875, any of these numbers dividing evenly into it, well, it would either be 729 or something smaller. Guys, 125 will do this. So we're going to be able to split him into the third root of 125 times the third root of, well, 125 times what gets you 875? It's 7. 7 is your leftover. All right, good, we took care of him. Now let's go to the 25. The third root of x to the 25th. Guys, does 25 divide by 3? No. So what's the closest number to 25 without going over that will divide by 3? 24. So we're going to split him into the third root of x to the 24 times the third root of how many x's are left over to get back to 25? Just 1. And then go to the third root of y. Guys, does his power of 1 divide by 3? No. Does anything smaller than 1 divide by 3? No. So guys, he's already a simplified third root. You can't fix him. He's going to be stuck underneath this third root forever. So this is going to stay the third root of y. I can't split him, and I can't take the third root of him. All right, now we go through, let's take the third roots that we can and leave the ones that have to stay. So negative 2x stays. What's the third root of 125? Look at your chart, third root 125, take it all the way to the left, it's 5. The third root of 7 was the leftover, so he stays. The third root of x to the 24th. Guys, 24 divided by 3 is x to the 8th. He is free, no more third root radical. All right, the third root of just x, that was our leftover. He's going to stay stuck. And then the third root of y, we said we can't fix that and we can't split it. So he's stuck. All right, and now we just go through. We're going to multiply anything that's not under a radical together and put in the front. And then anything that is under a third root, multiply under 1/3 root. It's going to finish this problem. So negative 2 times 5 are the only numbers. That'll be negative 10. X times x to the 8th broke free. That'll be x to the 1 plus 8 is 9. They're done. Now I would look for y's, but guys, no y's broke free. And everything else that is left is under a third root. So we're going to multiply them back together and put them back under 1/3 root. So that'll be the third root of 7 times x times y. So 7xy. Done, done, done. So it should feel very similar to last week's, except you're doing it with third roots and not square roots. Are you guys okay? You guys at home, are you guys okay? All right, so guys, I'm going to fill the other examples in and put them on the Post-it notes on Google Classroom like always, so you'll have them there if you want to look at them. Otherwise, you do have homework tonight on these problems. It's a Delta Math assignment, and it's due tomorrow night at 11:45. Let me know if you have any questions. Thank you guys for waiting. Let me know if you have any questions. I'm going to double check you two guys. I'm going to double check your attendance, and then you guys will be good to go. Sorry for going over.